This example explain the finding the design capacity under the axial compression force, which is concentric load grade 300, 200 universal column, 52.2 columns. The 3500 millimeter long column is pin ended, so the boundary condition are pin and can be buckled about any axis. So to find the column capacity can be taken minimum of section capacity and the member capacity. Buckling will occur about the section axis for which the slenderness L over R is greatest. So maximum L over R, that is the axis that will buckle first. Now section capacity NS. Now nominal section capacity, that is given on page number 81, that equations on page number 81, where you have a clause of 6.2.1. nominal section capacity NF can be found by KF, AN and FY. The notations are given here. Now KF is a form factors that can be found, and AN is the area that can be found from one steel table for 200 UC 52.2. 200 UC 52.2. we have a area is 6660. So 200 UC 52.2, that is the gross area of the cross section, that is given 6660 millimeter square, and the form factor is given on page number 17. 200 UC 52.2, and the form factor is given 1 here. So that's are taken from one steel tables, and substituting the value 1 times the area 6660 times the yield strength of this 200 UC 52.2, and the yield strength between minimum between 300 and 320, so the 300 is taken. So the multiplication gives in the newtons, and dividing by 1000 gives the 1998 kilonewton. There is a one more zero here, and dividing by thousands give us the in the kilonewton. Now once you find the section capacity, we can find a member capacity NC. So nominal member capacity is given in clause 6.3.3 on page number 83. On page number 83, at the end of the page, clause 6.3.3, section capacity is given alpha C times NS. Alpha C is a member slenderness reduction factor. Now we need to find the effective length first, LE, that is KE times L, that is given in clause 6.3.2 on page number 83. On the same page, we have a effective length in clause 6.3.2, that is the equation for effective length. Member effective length factor KE is equal to 1, that is given in the clause 4.6.3 on page number 43. On clause 4.6.3 member effective length factors on page number 43. Over the page on page number 44, we have a pin ended columns that is given in the question. So for that, KE value is taken as 1. Now it's given in the questions that is the pin ended conditions. So the KE value is 1. So the effective length is equal to KE, which is 1, times the length that is given in the question 3500, that is given in the question 3500 millimeters. Substituting that value give us 3500 millimeter. Now we need to find the biggest L over R ratio. For that L over R ratio biggest, for examples, we need to find the maximum L over R ratio to find the buckling axis. To find the maximum, we need to get the smallest radius of gyration. So we have two radius of gyration, which is about x-axis and about y-axis. Now from one steel tables, for 200 UC 52.2, 200 UC 50.2, and Rx value is 89.1, that is 89.1 millimeter, and the Ry value is 51.5, so that is 51.5. Minimum of this 89.1 and 51.5, the radius of gyration is 51.5 millimeters. Now once you find that smallest radius of gyration, we can find the modified member slenderness lambda n value, that is given on page number 84. On page number 84, we have a lambda n value LE over RKF FY on 250. Substitute the value. LE is 3550, that is we calculated just in the previous step, 3500 millimeter. Radius of gyration is 51.5 millimeters. Kf we found 1, that is in the previous sections. From the one steel table we found Kf form factor 1, and Fy is 300, that is coming from one steel tables. That is on page number 17, 200 UC 52.2. So the yield strength between 300 and 320 is 300. So that is multiplication gives 74.4. Now after finding the modify member slenderness, we can find member section constant alpha b. We need some values here. Kf equal to 1, hot roll universal column. So because it's in the one steel table, all the one steel tables manufacturing are the products are hot rolls. And from table 6.3.1 on page number 85, on page number 85 there are two tables given to find the member section constant alpha b, one for Kf equal to 1 and the second one is Kf less than 1. Now in our case Kf equal to 1, which is form factor 1, so in that case we need to use table 6.3.31 and the compression member section constant alpha b value. Now the alpha b value that we can find is equal to 0, because we can say different sections, and we need to find hot roll universal beam or universal column sections. So that's what alpha b value is 0, that is taken here. Now member slenderness reduction factor alpha c. Now member slenderness reduction factor alpha c can be found from page number 16. So write it down here, on page number 86 on table 6.3.3 on 3. That is the alpha c value. Now for the finding the alpha c value, we need to check lambda n value, which is 74.4 that we calculated here, and we need to get the alpha b value as well. We just calculated alpha b equal to 0, which is the compression member section constant. Alpha b is 0 and we have 74.4, which is close to here 75. So or we can do the interpolation between these two and we get 0.72 for the alpha c value. So alpha is 0.72. Now member capacity is 5 Nc, which is equal to member capacity alpha c ns. Now that equations that we obtain is from here. Nc is equal to alpha c ns, and that is 83. So 0.9 times 0.72 that we found, and this is section capacity. We found in the previous steps the section capacity on the first step 1998 kilonewtons. Substituting here gives 1295 kilonewtons. So that's the final answer. We need to take the minimum of 1295 and 1998, and obviously the slender member capacity is smaller, so the final answer is the member capacity 1295 kilonewton. Thank you.